Hello, my name is Ernick Guzman. Today I'm going to demonstrate that Albert Einstein made a mistake in his equations. A new quantum mechanical model is proposed. As I said earlier, the photon mass is 7.72497 multiplied by 10 elevated to negative 51 kilograms. And this formula presented is the new energy equation. Albert Einstein makes a mistake when he forced an equation for a photon to be massless at 1 cycle per second. To identify the mistake, only they use the energy obtained with his next equation and divide the result by the corresponding frequency. This error provides the equation to be equivalent at zero frequency with the famous equation energy is equal to mc squared, providing the kinetic energy of the photon. But the equation above does not describe exactly the nature and behavior of photons. When in the equation you provide a value of 1 cycle per second, the result is that the mass is equivalent to zero or no energy is present. Thus makes sense that at zero frequency you have an energy equivalent to energy is equal to mc squared, and at a frequency of 1 is 0, obviously does not make any sense. Photon does not have a relative mass. Its mass is equal to 7.7 multiplied by 10 elevated to negative 51 kilograms exactly. Here I present a numerical correction of Einstein's mistake with the Reynolds equation. Using his equation dispersed by mass for 1 multiplied by 10 elevated to 16 cycles per second, according to Einstein, Planck energy is equal to Planck constant multiplied by frequency is equal to 6.626 energy multiplied by 10 elevated at negative 18 joules. Then, as I presented here, this is the equation for mass, this is the formula dispersed by mass, and the result for the mass is here. But when you divide this quantity over 1 multiplied by 10 elevated at negative 160, you obtain that this value is this result here. And this is the same value as I provide for the mass of the photon in the present work and in the earlier works that I present on the web page, internet, and some documentation submitted to journals. Is the photon massless, or the photon is a massive quantity that is present in our world? But the answer is that this quantity is the photon mass, and to obtain the photon mass in formula, a value is needed to use this formula. This formula is the non-relativistic mass is equal to the Planck constant over c squared multiplied by the minimum frequency, that is equal, the minimum frequency is equal to 1 cycle over second. And the resulting product is the photon mass. Here I present the equation, our new equation, Guzmán-Einstein equation. This equation has the energy is equal to the mass of the photon multiplied by c squared. This proportion of the equation is of the form of kinetic energy, and the other part of the equation is the mass of the photon multiplied by c squared and multiplied by this part of the equation that represents the frequency of the photon with a extraction of 1 cycle per second, representing the 1 over second over this quantity 2. When you use the equivalence energy of the photon, mass of the photon, and the speed of light in the vacuum, the frequency of the photon, the minimum frequency, and this is the value of this minimum frequency. The equation presented is the best fit for a photon nature. I developed this equation correct. This equation provides the same Einstein results of energy but provides the correct mass of the photon. And here is the equation again. Here is the dispersion by mass. And here is using the past energy example. Manually is obtaining this quantity, but with Excel is equivalent to this value. For all frequency, the mass of the photon is the same using this equation. Using the Guzmán-Einstein equation for energy for zero frequency or 0 cycles per second. This is my equation. This is the part of the equation using the value of zero frequency in the equation. And when you use zero here, the product is negative, and the energy of the photon as a resulting of the equation is equivalent to mc squared. At frequency 1, a photon has the energy equivalent to 6.626 elevated to negative 34 joules, but is unable to be out of the quantum system, do not have enough energy to abandon the system. This was explained in the calculation process. This explains possible the presence of a dipole in the photon mass with slightly energy more than 1 cycles per second. The photon probably is able to abandon the quantum system. In this process, is like a shape or a round in the spin, and if the system does not have enough energy to contain this photon, the photon escapes from the system. Here is the result of the equation for energy of 2 cycles per second. Here is in the equation the value. This is the product of the equation using the calculation, and the result, the final result is that in photon with a frequency equivalent to 2 cycles per second have energy equivalent to this quantity. With this energy, a photon is possible to be found out of the quantum system. The energy to be out of the system depends on the system ability to attract or prevent the escape, a potential energy. But this is the demonstration that between 1 cycles per second and between 2, this is the minimum value of energy required theoretically to provide a photon escape, but every time it needs to be more than 1 cycles per second. Here I present the Guzmán-Einstein equation of relation derivative. This is the equation. Is very important, and with the Albert Einstein equation that it currently is available, it's not possible to determine the quantity or the derivative integrative of the equation, but with this equation that I created, it's possible to obtain this derivative. This provides us a lot of important energy about the photon's nature. Here is the Guzmán-Einstein equation of relation derivative. This form, in particular case, is in the mathematical equation of the Guzmán-Einstein equation. This is the frequency of the function A is equal to the kinetic energy, or mc squared of the photon property of kinetic energy, and B is the minimum frequency, or 1 cycle per second. That is the definition that I previously provide for minimum frequency, or Vmin. This is the final derivative. Note that this constant in the original equation is lost in this form because this equation only provides the frequency that a photon is able to transfer to another system. Not the frequency only. Note that it's not the kinetic energy that a photon is able to transfer. As a general property of this case in particular, important information is that a photon and that lost all first frequency, and later if it lost some of its kinetic energy, the photon is trapped in a quantum system if the system have the amount of energy required to maintain it in the interior of the quantum system. And this function represents the capacity of the photon that they make the change in terms of frequency in other system in joules per second, similar to the Planck constant that have units of joules per second. And here is the Guzmán-Einstein equation of relation derivative, providing for the zero frequency in the derivative equation. Here is the process that is taken, and this is the other process. This is the final result. Note that here in the result is a negative sign in the front. This negative 6.626 multiplied by 10 elevated at a negative 34 joules multiplied by second. A negative value of the derivative, a photon with frequency 0 or no frequency, is unable to provide energy according to our knowledge, has the capacity to absorb energy when it is at this frequency. This demonstrates a photon without kinetic energy trapped in a quantum system. Maybe it's not exactly 0, but this value is in reference to kinetic energy, and that or without kinetic or a kinetic energy that is very, very small in the form of frequency probably. And here is the same equation, but for a frequency of 1 cycles per second. Here is the primary equation turns in this form, and finally in this form. The resulting value of the equation is 0 joules per second. When a frequency is exactly 1 cycle per second, the photon is unable to provide any energy in form of frequency or kinetic energy. The photon has the minimum required kinetic energy, but is unable to be out of the system. The frequency needs to be at a minimum more than 1 cycles per second, like spin change in the nuclear magnetic resonance technique, to going out. This is the more than 1 cycle per second is the minimum energy required to be out of the photon, but at this quantity of energy exactly, the derivative provides to us that is unable for a photon to be out, but unless it have the kinetic energy. The kinetic energy is present, but is the last energy that is lost. It depends on the system. It explains the photoelectric effect. And here is with a frequency equal to 2 cycles per second. The result of the derivative is this value that is equal to 6.626 multiplied by 10 elevated at negative 34 joules per second. This is the maximum frequency that a photon provides to another system and the kinetic energy, but is the last energy property that is lost. The kinetic energy is not contained in this result because it's not part of the frequency provided for this particular equation. The energy that here is this energy is only the frequency or the momentum that the photon can have the ability to transfer to another system, to another quantum system, such as proton, electrons, neutrons, or nuclear atoms. And note that here I have the Guzmán-Einstein equation of relation, in particular the integration process applied to the equation. This is the final result of the equation in this form mathematically, and in this form as a physical system equation. This equation provides values of work or watts that a system requires to provide the photon with the particular frequency its energy. This is the process taken to resolve the equation. This is the final result of the integration that is equal to 6.626 multiplied by 10 elevated negative 34 joules over second or watts. This quantity represents the work required to provide the rest mass of a photon with kinetic energy to be at least at mc squared. With only this energy, a photon is unable to escape from the quantum system, as I stated before. When I applied to the equation a frequency of 1 cycle per second, the process is here and the result is here. It's the work necessary that a system needs to provide to the photon to be in energy state of 6.626 multiplied by 10 elevated at negative 34 joules, as demonstrated in the respective derivative, remembering that the photon requires more than 1 cycle per second to abandon a system using the momentum. Remember again, the quantum system requires more than this energy. It's a minimum required value. A slightly more of this work and is possible in an emission of a photon. But this is the minimum quantity of work required to be at the mc squared value. And here is the equation of integration when frequency is equal to 2 cycles per second. The process here and the result is here. 1.9878 multiplied by 10 elevated at negative 33 joules over second or watts. This is the work required by a system able to emit a photon at 2 cycles per second. For a photon with 1.3252 multiplied by 10 elevated to negative 33 joules. Here is a last chart that I present to you. Here is the watts that is obtained for integrative. Know that this quantity is represent the energy or the energy, not the work required for a quantum system to be provided for a photon to create a particular photon of these frequencies. And here is the derivative, that is the energy that a photon has the ability to transfer in form of frequency, or maybe you call it a momentum. In this form, note that it does include the quantity related to kinetic energy. When a photon loses any amount of kinetic energy, it has a high probability to be trapped by the quantum system. And in the last column is present the formula that I proposed for obtain the energy of a photon. Here is the results. Know that when you obtain the value of the integral here, you obtain the what's required for a system for a photon mass of 0 cycles per second to be increased to mc squared. This is the energy that a photon can provide to another quantum system, or the system that it is located. It absorbs this quantity of energy of a system that it is located. And finally, in this row, this is the energy of a photon, with the formula proposed is 0, because the photon does not have enough energy to be at the value of mc squared, and is trapped in a quantum system. When a photon has a value of 1 cycle per second, this is the work that is required for a system to move it to the quantity of energy equivalent that and is located here, but that this photon in particular in 1 cycle per second is unable to transfer any energy. It is like the photon is located in an orbit around the quantum system and is waiting for going out of the photon or to lose energy and be in a more stable energy. And here is the other quantity with 2 cycles per second, and the integrative product is the watts, and this is the work required for the this is the work required by the quantum system to be provided to the photon to be at a frequency of 2 cycles per second with an energy that is equivalent to this quantity, and that the ability to transfer any type of energy in frequency is of this quantity only. And finally, when I use another high energetic photon, this is the value of the high energetic photon. This is the work required by the quantum system to provide a photon with this quantity of energy that is provided here. Note that the difference when the frequency is too high, the energy is too high, it not appears different. Why? Because both quantities do not have any effect of the mass of the photon. Only at low frequencies is noted the effect of the mass of the photon, and that is located here. Note that at high frequencies, the work required to create a high energy photon is very high, comparable to the energy of a photon. This implicates that a system with high potential energy, or if you like to call it gravity, to release the photon is very high. Part of this work is loosed as negative quantum potential energy or quantum heat. And thank you for looking my video, and I think that this is the new quantum theory, and the quantum theory that we know today is changed.